Alright class, you are welcome to another exciting video lesson on my YouTube channel. Now in today's video lesson, we're going to be talking about something very interesting in the world of chemistry. Now we're going to be discussing the Chatelier's principle. Chatelier's principle, one of the most famous principle, alright, in chemistry. Now the Chatelier's principle is usually studied under a topic called chemical equilibrium. The Chatelier principle is studied under a topic called what? Chemical equilibrium. Now, what does the Chatelier principle state? It says when an external constraint, alright, is imposed on a chemical system at equilibrium, the system will shift so as to neutralize the constraint. So when an external constraint, or you can put it as when an external factor is imposed on a chemical system at equilibrium. So something that is at equilibrium is something that is at rest. At rest. So a system is already at rest, and then you impose external factors or external constraints. Now, what will happen is that it's going to cause a shift in the equilibrium of the system. So the equilibrium we now have to neutralize, all right? We adjust in order to neutralize the constraint. Now, the key word here is the external constraints, or you say external factor. Now, the external constraint or external factor can be divided into three groups. We have change in temperature, change in pressure, and then we have what? Change in concentration. Alright, so we have change in temperature, change in pressure, and change in concentration. So change in temperature, change in pressure, and change in concentration. Alright, these are the external constraints that can have effect when they are imposed on a system at equilibrium. Now we are going to study how these different factors affect the system at equilibrium. We're going to discuss each of them one after the other. Now let's start with change in temperature. Change in temperature. Alright, so what will change the temperature do to a system at equilibrium? Alright, now you should know that based on temperature, we can have two types of reaction based on temperature. We have what? Endothermic reactions, and then we also have what? Exothermic reactions. Now, endothermic reactions, they absorb heat. Then for exothermic reactions, they gives out heat. Alright, so exothermic, exo gives out heat, endo absorb what? Heat. Alright, now another thing you need to know, for endothermic reaction, delta H is positive, and then for exothermic reaction, delta H is negative. Are you getting it? For endothermic reaction, delta H is positive, then for exothermic reaction, delta H is negative. Now, pay attention to the most secret thing. Alright, under this temperature, there's one thing that stands out very, very well under this change in temperature. And if you can understand this thing I'm about to show you, alright, all your worries about the Chatelier's principle ends. Alright, now listen to this. Take for example, you have this reaction A plus B to give C plus D. Take for example, you have this. Alright, you have this. Now, what you will observe is that if, for example, at the end I put something like delta H positive. So what this thing is actually telling you for this reaction is that what it means is that the forward reaction, which is your right hand side, the forward reaction, which is what your right hand side, your product side. So the forward reaction is endothermic, and the backward reaction is what? Exothermic. So if I give you another thing, E reacts with F to give you G plus H, and I put delta H equal to negative. What it therefore means for this reaction, delta H negative, what it means for this reaction is that the forward reaction, your right hand side, is exothermic, and then your left hand side is what? Endothermic. Right, so what it means is that your right hand side is exothermic and your left hand side is what? Endothermic. Your right is exo, your left is endo. When you see delta H negative. But in a reaction, if you see delta H positive, it means your right hand side is endothermic, your left hand side is what? Exothermic. You have to take note of this. You have to take note of this. Very, 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 very important. All right. Now, another thing you also need to open your mind to is on the area of the constant, the equilibrium constant K. All right. Your equilibrium constant K. Listen, your equilibrium constant K. All right. It increases and decreases depending on if the reaction is endothermic and if the reaction is what? Exothermic. So what increases your equilibrium constant K for endothermic reaction is not what increases your equilibrium constant K for exothermic reaction. Now I'll quickly show you the secret. Now this is where most students, all right, and some other tutors forget to teach, and where most students never even pay attention to. And jamb, waec, and post-UTME examination, they ask questions from this area. Now watch this. This is what I want you to take note of. Now the first thing is that for endothermic reaction, as temperature increases, are you there? K, which is our equilibrium constant, K also increases. Now I'll show you where this is very much applicable. By the time we proceed, I will also make reference to this. All right. Now for exothermic reaction, as temperature increases, K decreases, and vice versa. Now, what do I mean by vice versa here? Now, for exothermic reaction, if you increase the temperature, K will decrease. But if you decrease the temperature, K will increase. So for exo, please, for exothermic, as you increase the temperature, K decrease. So for exothermic reaction, if you want to increase the K, which is your equilibrium constant, if you want to increase the K, your equilibrium constant, for exothermic reaction, you have to decrease the temperature. So for exothermic, if you increase temperature, K will decrease. If you decrease temperature, K will increase for exothermic. Then for endothermic, if you increase temperature, K would increase. And if you decrease temperature, K will also decrease for endothermic. So for endothermic, if you increase the temperature, K will increase. If you reduce the temperature, K will be reduced, or K will decrease. Is that clear? Now, let's now move to a more important stuff, all right, pertaining to still the temperature. Now, I will not want to clean this stuff. It's very, very important. All right. Okay, now let's run through something that we always find very helpful. All right, So this one is applicable for endothermic reaction. Please don't forget it. Now, this is where the main secret lies. Now, in order for you to be able to answer questions, this is where the main secret lies. All right. So, secret number one. All right. Secret number one, for endothermic reactions. For endothermic reactions, an increase in temperature, favors the forward reaction. Then for exothermic reactions, all right, a decrease in temperature favors the forward reaction. All right. So if you look at this one here, if you see for when delta H is positive, all right, that's endothermic, you discover that the forward reaction is endothermic and the backward reaction is what? Exo. So it therefore means that if you want to favor the forward reaction, what do we do? According to this, we need to do what now? Increase the temperature, because increase in temperature favors the forward reaction. So because the forward reaction, all right, is endothermic, in order for us to push the equilibrium system to the right, or in order for us to favor the right hand side where you have the endothermic, we have to do what? Increase the temperature. So increase in temperature favors the right hand side, which is what? Your endothermic side. All right. So it therefore means that for this reaction where you have delta H positive, which implies that the forward reaction is endothermic, the backward reaction is what? Endothermic. So when you want to push the equilibrium position to the right, when you want to favor the right hand side, when you want to shift the equilibrium system or position to the right, that is endothermic, you increase the temperature. So increase in temperature favors endothermic reactions, all right, while decrease in temperature favors what? Exothermic reaction. So decrease in temperature favors exothermic reaction. So if you look at this guy, where you have delta H negative, so it means that the forward reaction is exothermic and the backward reaction is what? Endothermic. So the forward reaction is exothermic. So when you want to favor the forward reaction, all right, where your delta H is negative, when you want to favor the forward reaction, you will have to what? Decrease the temperature. Are you getting it? So what you can now observe is that whenever I want to favor endothermic reaction, we increase the temperature. Whenever I want to favor exothermic reaction, we decrease the temperature. So if you are not giving this, for example, all right, if in this reaction, this particular one, A plus B to give C plus D, so delta H is positive, which means that your forward reaction is endo, your backward is exo. So for this case now, if you want to shift the equilibrium system to the left, which is exothermic, you want to shift the equilibrium position to the left, you want to favor the left hand side, that is your reactant side. You want to favor your reactant side, which is exothermic. Now, how do you simply do this? You do this by decreasing the temperature. So it therefore means that any direction that you can discover your endothermic or exothermic, all right, any direction. For example, now in this question, the forward direction is the endothermic, the backward reaction is what? The exothermic. So it therefore means that increase in temperature will favor the forward, while decrease in temperature will favor the backward, which is exothermic. Then in this reaction, where the forward reaction is exothermic because of our delta H, which is negative, the forward reaction is exothermic and the backward reaction is what? Exothermic. What it therefore means is that to favor the forward reaction that is exothermic, we need to decrease the temperature, and to favor the backward reaction that is endothermic, we need to what? Increase the temperature. So any direction you see that is endothermic, maybe through your analysis, once you just see delta H positive, just know that the forward is endo. The backward is what? Exo. When you see delta H negative. Now, sometimes they might not put it as positive and negative like this. They might put it as actual numbers, actual values. Here you see something like this can be plus 208 kilojoules, while this can be minus 67 kilojoules, for example. So once you just see this guy is negative, so it's telling you that the forward is exo and the backward is endo. This guy is positive. It is telling you that the forward reaction is endo, the backward is what? Exo. So if you discover the backward to be exo, if you want to shift the equilibrium position to be back, what do? You decrease the temperature because the back is what? Exo. Then if you discover that the back is endo, in the case of this guy, when you want to shift the equilibrium position to the left, you must do what? Increase the temperature. So to push the equilibrium position to endothermic side, you have to increase the temperature. To push the equilibrium position to exothermic side, you have to what? Decrease. You have to do what? Decrease your temperature. So now look at this guy again. These two guys. We are back to this again. Now, breaking these two guys down, this we said as temperature for endothermic, as temperature increases, K also what? Increases for endothermic reaction. So it simply means that for this guy, all right, when we increase our temperature to favor endothermic, what is happening to the equilibrium constant? It is decreasing. Then when we decrease our temperature to favor the exothermic side, when we decrease our temperature to favor the exothermic side, what is happening to our K? All right, our K is what? Increasing. But when we now increase temperature, all right, when we increase temperature for exothermic, the part is exothermic, and you now want to increase temperature, all right, for exothermic. So what is happening is that our K do what now? Decrease as a result of increase in temperature. So this entire reaction, all right, this entire reaction is positive, all right. So this entire reaction is positive. So when we increase our temperature, okay, when we increase our temperature, now our C and D, C plus D, which is endothermic, the K would increase. But for our A and B, which is exothermic, the K on our A and B, which is the exothermic, it will what? Decrease. For this guy, G and H is exothermic. So when we decrease the temperature, the K for G and H will increase. Then for this guy, all right, when we decrease the temperature, the value for E and F, the K value for E and F would decrease because decrease in temperature for endothermic, as temperature increases, K also increase. If the temperature decrease, K also will decrease. Then for exothermic, as temperature increases, K decreases. And as temperature decreases, K would also increase. So this is all for change in temperature. All right. So please, you have to watch this video over and over and over again and get questions and try to use the knowledge of this video to answer the questions. All right. You see that you're going to get it. But please, I want you to go over this question again, and again. Go over this thing I just explained here, this explanation. All right. Go over it again and again and again. All right. You'll get it. Okay. It's very easy. You're going to understand the concept. All right. So by the time you watch this video over and over again, try to answer questions. You see all the pieces we start coming together and start making a lot of sense. Now let's go to another area, which is what? Change in pressure. Concerning the effect of change in pressure, how do we do this? Now please note that pressure only affects a system of gases. Pressure only affects a system of gases. And I go back again, I repeat myself. Pressure only affects a system of gases. So it therefore means that if you have this, for example, A plus B to give C plus D. Now, for pressure to have an effect for this chemical reaction or this chemical system, for pressure to have effect, what we need to ascertain is if all of them are in the gaseous state of matter. And how can you do this? Please, when it comes to this area of chemistry, always pay attention to those stuffs written at the down, right? Sometimes you see some written as AQ, that's aqueous. See some S, that's solid. L, liquid. G, gas. All right. So I didn't put this one out for change the temperature because we're not going to be needing them for temperature. But when it comes to pressure, we're going to be needing them very, very well. Now, for pressure to have effect on a chemical reaction system, all of them must be in the gaseous state of matter. So I'm not talking about two of the reactants and one of the products are in gas. And if the other one of the product is solid, then it does not matter. No, I mean all of them must be in the gaseous state of matter. If there is only one that is not in the gaseous state of matter, probably that one is a liquid or a solid. Pressure will not have effect. So pressure can only have effect if all of them, pressure can only now have effect. Pressure can only have effect if all of them are in the gaseous state of matter. That is when pressure can have effect if all of them are in the gaseous state of matter. Are we together? All right. Now, if it is discovered something like this, gas, so pressure can have effect. Now, what was the effect of pressure? How do we break down the effect of pressure? Now, the effect of pressure goes like this. All right, it goes like this. The part with a higher volume, or number of moles, the part with a higher volume or number of moles is favored by decreasing pressure, while the part with a lower volume or number of moles is favored by increasing pressure. So that's what we have. All right. So the part with a higher volume or number of moles, that part is favored by decreasing the pressure, while the part with a lower volume is favored by increasing the pressure. Just like Boyle's law. Boyle's law says that the volume of a fixed mass of gas is inversely proportional to its what? Pressure. So it therefore means that if the volume is high, V inversely proportional to P. Now it means that this V is high and this P is low. So for a high V, decrease the pressure. And if we write this, we put it as P inversely proportional to V. It therefore means that if you increase the pressure, the volume will decrease. So if you increase volume, pressure will decrease. If you increase pressure, volume will decrease. So that is the reason why decreased pressure favors high volume. If the volume is high, decrease pressure. Lower volume, if the volume is low, increase pressure. That's what it works. If the volume is low or the number of moles is low, increase pressure. If the volume or number of moles is high, decrease pressure. So now we can understand this when you have a practical chemical equation that was balanced or that has been balanced. So I can just formulate something here now. I can say, okay, I decide to just put 2 here. All right, I decide to put 2 here, and then I put 3 here, for example, or let me put it 3 here. So I put 3 here. I put 3, all right, in front of G, and I put 2 in front of A. So now we want to get the number of moles. Now you get your number of moles of a reaction from the balanced state of the reaction. So I just assume this reaction is balanced by putting 2 in the front of A and 3 in the front of D. So to now get the number of moles or volume, all right, to know which side, which part, is it this left hand part or the right hand part, which direction has a higher volume. So how do we know the direction that has a higher volume? The direction that has a higher volume, this is how we determine it. You can either say higher volume or higher number of moles. This is how we determine it. Now there's 2 in front of A, there's nothing in front of B. Nothing means 1. So 2 plus 1, that is what? 3. So on this part, all right, so on this part, we have what? 3 volume, or we say 3 moles. All right, then on this part, there is nothing here, right? Not that's 1. 1 plus 3 in front of D, that is what? 4. So on this side, we have 4 moles, or we say 4 volume. Okay, let me put it this way. 4 moles or 4 volume. Now, between this and this, which one has a higher mole or a higher volume is what? This part. So it therefore means that when you want to now shift the equilibrium to the part with a higher volume or the part with a higher number of moles, when you want to shift the equilibrium position to the part with the higher number of moles or the higher volume, what do? You are going to do what? Decrease pressure. All right, we're going to decrease pressure. Then when you want to now push the equilibrium position to the part with a lower volume or a lower number of moles, what are we going to do? We are going to do what? Increase pressure. So what we are going to do is that we are going to increase what? Pressure. So this is the summary of everything. Before you use pressure, before you start looking at the reaction, which side has a higher volume or the side that has a lower volume, you have to pay attention to the main thing. Does all the reactants and the product, are they in the gaseous state of matter? All the reactants and all the products, are they in the gaseous state of matter? If yes, then you cannot proceed to finding the ones with a higher volume and the part with a lower volume. If no, please just simply know that for that reaction, all right, if all the reactants and products are not in the gaseous state of matter, just know that for that reaction, pressure cannot have effect. It's the breakdown of it. All right, so this is it. Okay, now practical reactions, you can see this in practical reactions like actual examples. I'm just using letters to represent those reactions, but then there are actual examples that we'll see if you go through your questions pack. All right, now let's go to the final area, which is what? Change in concentration. Now concentration means something that is more. Now if at this point you have not subscribed, please do it to subscribe, turn on your notification bell, like this video, and please share this video to save life. All right, so please share this video to your other social media, right? Share it on your WhatsApp page, share to friends and family so that they can see this video and learn. All right, so change in concentration. Now concentration talks about amount. All right, that's what it means. Amount. How much? How is it many? Nigerian people will say I many rich. I say many. That is concentration. All right, how much? Okay, so now looking at concentration, the concentration has the most simplest principle to go with. All right, the most simplest hack is for concentration. Now for concentration, look at it. If, or let's put it this way, addition of chemical species to one part favors the opposite part, right? Then removal of chemical species for one part favors that same part. All right, is that clear? So as simple as it is, this is what we have. All right, simple as it is. So now let's break this down by using this reaction. So we have A plus B to give us what? C plus D. A plus B to give us what? C plus D. Now, the principle about this concentration is simple. Addition of chemical species to one part favors the opposite part. So it therefore means if I add to this part, it's going to favor what? The opposite part, which is what? This part. That's concentration. Whether I tell you addition of more of A or addition of more of B. So long I am adding to this part, even if I'm adding A or B, does not matter. But so long I am adding to this part, this left hand part, the right hand side, which is the opposite side of the left, is favored. If I'm adding to my right, which can be addition of C or D, alright? It could be addition of C or addition of D, does not matter. But so long the addition is occurring at the right hand side, alright, the left hand side is what? Favored. Then if I am removal of chemical species to one part favors that same part. So if I remove from this side, it does not matter if it is A or B I am removing from. If I say removal of A or removal of B is the same thing as removal of one part, which is the left part. Right? When you remove from the left part, which part is favored? That same left. Removal from the left favors the left. Removal from the right favors the right. Addition to the left favors the right. Addition to the right favors the left. Removal from the left favors the left. Removal from the right favors the right. So when you add, the opposite side is favored. When you add, the opposite side is favored. When you remove, removal of B favors the left hand side where you have B. So removal favors that same part. Removal from a particular part favors that same part. Then removal from this part, this particular part, favors this same part. That is how it is. So when you remove from here, it favors here. When you remove from your right, it favors your right. When you remove from your left, it favors your left. When you add to your right, it favors your left. And when you when you add to your left, it favors your right. When you add to your right, it favors the left. When you remove from your left, it favors the left. And when you remove from your right, it favors what? The right hand side. That is it about concentration. It's very, very easy. So the removal can be, they will not just say remove from your left. The removal can be removal of C. So you know that C is on your right hand side. So removal of C, which is on your right hand side, that right hand side is favored, which is the forward direction. Removal of A, which is at your left, it means your left hand side is favored. So they can call any of the chemical species from the left or the right. You just have to be sensitive. All right. So this is where we draw this video to a close. Now, stay tuned for my next video, because on my next video we are going to be looking at question series under this Chatelier principle, and I'm going to be breaking down question. All right. So please, thank you for watching this video to this very point. I love you, and I'll see you in the next video lesson. Peace.